Hello, college algebra. I hope you all are doing well. Welcome to day 5 of our unit. Today we are going to talk about how do you graph logarithmic functions, and we are going to rely heavily on what you know about exponentials and inverses to be able to accomplish this. So please understand that when you're graphing things today for your homework, it is my expectation that you will probably make 3 tables of values each time to get 5 points that are really good to graph. And if you need graph paper, you're welcome to use the PDF that I'm going to have linked up to your homework. And if not, that's fine. But please make sure that you're plotting 5 points precisely for each graph that you do. All right. Stop in on office hours if you need anything, and I will gladly try to help you out. Let's go ahead and try to screen share here and see if my technology will work for us, because it's always questionable. All right. Looking good for now. Okay, so we only have 2 lessons this week because both of them are fairly long lessons, and so I thought that would be an easier way to kind of handle things rather than trying to do 3 lessons. There was just no great way to break things down, okay? So today we're looking at logarithmic functions and their graphs, and that's what we're focusing on for today, okay? So we're going to start, and unfortunately I can't get everything on this paper, but we're going to start with what we know, which is exponential equations, and we're going to use inverses to be able to help us find the graph of the inverse of an exponential. And it just so happens that the inverse of an exponential is a logarithmic function. Okay, so if I have to graph f of x equals 2 to the x, there's my x, there's 2 to the x. What I'm going to know is that there's no transformation on this, and so we'll just focus around -2, -1, 0, 1, and 2. And if I plug in, my input, right, is an exponent. And so on something like this, your exponents are allowed to be any number you want. They can be positive or negative. So 2 to the negative second power is 1/4. 2 to the negative first is 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 to the second is 4. And so we could plot these points. -2, 1/4, and this is going to be rather difficult because it's so tiny. Come on. And then -1, 1/2 is somewhere around in there. And then 0, 1 is there, 2, 1, 2 is there, and 2, 4 is about right there. Okay. I should have made a bigger graph, but it's really hard on my tablet to graph this. So this graph should be flat. And that's not, oh, I don't want a line. It should look kind of like that. Hopefully you can go through your points a little bit better. But graphing exponential, it kind of looks like this. It does go along an asymptote. My domain for something like this, we're talking about the inputs of an exponent, and your domain for an exponent can be any number you want. So those are all reals. The range that we're dealing with are real numbers, and we're going to say y is greater than 0, okay? And as we kind of go through and have to do these things for our test, we're just going to stick with either writing things as, we're going to use all reals, or y is greater than 0. Because I know that when we get to the test, and we have to do the test on Schoology, you don't have the ability to be able to type as much as you could if you wrote the things down. So asymptote here is y equals 0. Okay, so we are focusing today on graphing logarithms, and when you graph logarithms, well, logarithms are actually inverses of exponentials, okay? So how do we graph an inverse? Well, how about this? If you graph the inverse and you're using a table, well, all you have to do is switch x and y. So now for my inverse function, my inverse is actually the log base 2 of x. That's the equation for it. This first point would be 1/4, -2. My next point would be 1/2, -1. I get 1, 0, 2, 1, and 4, 2. All I'm doing is switching the points in the table. And so then when I do that, oh shucks, I should have also put on here that I've got an asymptote down here at 0, y equals 0. Okay. So those are my points of values. And so I could plot the point 1/4, -2, and this is, again, going to be really hard for me to plot. It's just not wanting to stick on there. 1/2, -1, somewhere around in there. 1 comma 0 should be right there. Come on. 2 comma 1, and then 4 comma 2. Sorry about that. Okay. So we can plot points that way, and that's not too difficult. We'll utilize that quite a bit. But what other things you should remember is that when you have inverses, the domain becomes the range, and the range becomes the domain. And for asymptotes, instead of y equals, it's going to be an x equals 0. So actually, I do have an asymptote, and it'll go up vertically at x equals 0. We had a range for the exponential function of y is greater than 0. So it will switch to x is greater than 0 for the inverse. The domain for the original function was all reals, so the range for the inverse will be the same, which is all reals. And if we go ahead and plot this graph, we should get, oops, I get same color, we go along this asymptote and through those points, okay? In general, a logarithmic graph will either be increasing or decreasing, much like an exponential graph. Over here, we had a base of 2. So 2 means it's a growth function. And over here, we have a base of 2 as well. And so it's also going to be an increasing function or a growth function because it's getting larger from left to right. Okay, and that's because your base is bigger than 1. Okay, all right. And so let's go ahead and try to continue on with what we know about logarithms and exponentials, okay? Every logarithmic function will be of this form right here. And we kind of need to know what happens with all of those different variables. When you're talking about the logarithmic function, this b is dealing with the base. And that's not something we've had to really kind of worry about before. But please notice if your base is bigger than 1, like it just was, it will be an increasing function, okay? If the base is smaller than 1, now notice your base, we already talked about this, cannot be 0 and it cannot be negative. And so as a result, this is what it would look like for being a decreasing function. Notice it's got a vertical asymptote on both of those. So those are kind of interesting points to kind of think about. Okay, but on our trig function, or I'm sorry, not our trig function, but on our graphs of our logs, we need to know what happens with the A, the B, the C, and the D, and if they change, how that happens, okay? If you're changing something on the inside of your function, this bx plus c, okay, those are dealing with all x value changes. Notice here, your domain is where the inside is positive. Where does this whole inside, this whole thing, where is that greater than 0? And if we solve that, that'll tell you your domain. Where it actually equals 0, that's your vertical asymptote. That'll be an up and down dotted line. And you are able to flip your graph left to right if b is negative, okay? And what that would look like, I'm gonna try to scooch this up a little bit. If b ends up being negative, then you would have your asymptote on the right, and on the left would be your graph. That's what I'm talking about with b flipping, okay? That would be for a growth function. If it was a decay function, you'd have your asymptote on the right, and then you'd have a decreasing graph, okay? All right. The other two changes that you have to kind of be aware of is that there are two exterior things that can happen, okay? So A is on the outside and D is on the outside. D will shift you, D kind of shifts you up and down as far as that's concerned, just so you kind of are aware of that. That can also impact where your let's just scratch that out. I don't want to talk about that. It can also impact your y-intercept. This A out here can change your y values by stretching them or shrinking them. And then if A is negative, it can make your graph flipped top to bottom. And what that would look like, when you talk about A changing, typically you have your asymptote on the left, and you can be a growth function, an increase, or you could be a decay function. And so when you are talking about flipping top to bottom, you are talking about flipping from being an increasing function to a decreasing function, or a decreasing function to an increasing function. So it could flip you that way. Okay, so that's all that's kind of going on with the values for A, B, C, and D on a logarithmic graph. These are the same things we've seen all school year, no matter what type of function you're dealing with. How does it move left to right? Well, how do you move a graph left to right? That always deals with the inside of your function. How do you move a graph up and down? Well, that still deals with the outside of your function, okay? So those rules are not changing for us. Let's graph a couple of these, and you're gonna notice on each graph, I am trying to have you do 3 tables for that. This graph has a base of 3, so it should be a growth graph. It should get bigger left to right. So you should have kind of like your dotted asymptote, your vertical line, and it should go up, left, right, okay? We're gonna start though with our exponential graphs. And we're gonna start with the basic exponential graph with the same base. And we're just gonna focus around the origin, because that's easy. And so then I'm going to talk about what's the inverse graph, what would those points be, and then we're going to talk about the transformation graph or the translated graph, okay? And so that's kind of what's going on with these 3 tables. So here's our exponential graph. Here's our, and then we'll switch the inverse to get the log graph, and then we'll transform the log graph, okay? So when I plug in -2 to 3 to the x, I get 1/9. When I plug in -1, I get 1/3. When I plug in 0, I get 1. When I plug in 1, I get 3. And when I plug in 2, I get 9. Okay? So we're going to start off then just looking at the inverse. And the inverse is x, comma, the log base 3 of x. All right? What does that set of points look like? Well, just like we did on the first graph, flip your x and y in your table. All right, so 1/3 goes with -1, 1 goes with 0, 3 goes with 1, and 9 goes with 2. And then, if you've got a transformation going on, then you would use this table and fill it out. Now, for us, there is no transformation. We're just graphing a basic log graph, so we don't have to worry about transforming anything. So we're just going to go ahead and plot things the way they are. 1/9 -2. 1/3 -1, come on, plot. 1, 0, 3, 1, and 9, 2. And so you've got some points. Let's go down here and talk about your asymptotes and your domain, okay? If I went ahead and took my, my inside of my graph was x, where is that positive, okay? Well, that tells you your domain. X is greater than 0. There's nothing I have to do to solve. Where that equals 0, is going to be my asymptote. And my range for all of these is all reals. Okay? And so what that told me here is my asymptote is x equals 0. So let's go ahead and draw that in. And my asymptote is right here. Wonk, 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 wonk. And that'll kind of help us rein some things in. And if I plot my points correctly and draw my asymptote, you go along my asymptote through my points, that's what my graph should look like. Okay. I'm also going to ask you other important questions like, what's your x-intercept? Well, my x-intercept is always a number, 0, and I actually calculated it for myself. So it's 1, 0. My y-intercept is always 0, some number, but in this case, it's my asymptote. All right. And this function is going up, left to right, so I'll call it an increasing function. And we're going to usually base that on your base. Okay. So there's the graph for that. Now we're going to move on and try another one. Here's our second graph. So if you want to copy that down, if you have to, that would be good. Okay. The big picture on this, this graph is shifted right 2 and up 1 from the standard graph. What's the base? Well, my base seems like it's missing. My base here is base 10. Okay. So when I talk about my tables here, this is going to be x and 10 to the x. That's my exponential table. And then I'm going to switch to my logarithmic table. So that's going to be x and then the log base 10 of x. And then my final table is going to be my transformation table. I'm supposed to go right 2. That means my x values all have to increase by 2. Outside is a +1. That means I increase by 1. So all my y values have to add 1 to them. Okay. And before we continue on, let's also talk about your asymptote. And my asymptote and my domain are all going to come from, this inside piece, okay? Where does x minus 2 remain positive, and where does x minus 2 equal 0? Excuse me. X minus 2 is greater than 0 when x is greater than 2. All right, there's my domain. X is greater than 2. If I solve this, I get x equals 2. That's my asymptote. Okay, so I've got an asymptote at x equals 2. Let's draw that in. That'll help us, okay? And then let's go ahead and start crunching some numbers to get some points. We'll start with the base, with the exponential. We're starting right around the origin. 10 to the negative 2 is 1 over 100. 10 to the negative first is 1/10. 10 to the 0 is 1. 10 to the first is 10. 10 to the second is 100. Okay. Now we're going to find the inverse of all of that. So we flip our points. 1 over 10, negative 1. And then our final step to get the right points to plot, I want everything to move right 2. So I'm going to take all my x values and add 2 to it. So I'm going to call this 2 and 1 over 100. I'm going to add 2 to 1/10 and get 2 and 1/10. I'll add 2 to 1 and get 3. I'll add 2 to 10 and get 12. I'll add 2 to 100 and get 102. Now for my y values, this graph shifted up 1. And so I'm just going to add 1 to all my y values. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. Add 1, add 1, add 1. These are the points I actually want to plot on my graph. Okay, go over 2 and a 100th and down 1. So go over 2 and a 100th and down 1. Come on. Come on, there you go. Go over 2 and a 10th and up none. Come on, plot a point for me. 3, 1 is right there. 12, 2 is right there. And the next one, I can't really plot. Hey, a base 10 is a really steep exponential graph. And so when you talk about a logarithmic graph, it's a very steep curve, okay? It's not growing very fast, but it's a very steep kind of corner, okay? Hey, my range on this is all reals. If I talk about my x-intercept, I calculated it out. That's right there at 2 and a 10th, 0. My y-intercept, look, I don't ever hit the y-axis, right? There's no y-axis that I'm hitting. Oops, why is it doing this to me? Okay, there's no y-intercept, so I'll just say none. And this graph would be considered increasing because the base was a base of 10. Okay, so there's my graph. Those are my points. You will be expected to be able to calculate the points, and this is kind of how I expect you to do your homework tonight. Okay. All right, let's graph a few more here. I think I've got 4 examples in case you're kind of keeping track, and example 4 is probably the most difficult if you need to kind of push ahead, okay? All right, here my base is 4, and so I'll have x, 4 to the x. And then if I talk about what are my inverse functions, I'm going to do x and then the log base 4 of x. And then if I talk about my final graph, what's my transformations here? Well, there's a negative on the outside. That goes with my y values. There's a -6 on the outside. That also goes with my y values. So all my y values, I'm supposed to make them negative, and then I'm supposed to subtract 6. Okay? Let's try that again. I don't know why it's not working. Negative y minus 6. Now, as far as the x values are concerned, these x values, well, if we go down here, x plus 1, where is x plus 1 greater than 0? That tells you your domain. X is greater than -1. Where does x plus 1 equal 0? That tells me my asymptote. That's at -1. So x equals -1. The range for every logarithmic function is all reals. Okay. So that should help me kind of give it I have an asymptote at least. My asymptote is at -1. Sorry, the dotted line thing just does not work well here. And if we continue on, that means that all of this graph is shifted left 1, it's down 6. And so I want to take all my x values and actually subtract 1 from them. Okay, let's go ahead and crunch some numbers here. Let's plug in -2, -1, 0, 1, and 2 to where my starting point is. That's a 16th, a 4th, the 1st, it's equal to 1. To the 0, it's equal to 1. To the 1st, it's equal to 4, and then we get a 16. All right, let's transform this so we have points for a log. This is 1/16 -2. 1/4 -1. 1, 0, 4, 1, and 16, 2. And for our final points, and these are the points that we'll actually graph, all my x values, I'm supposed to subtract 1. So 1/16 minus 1 is -15/16. 1/4 minus 1 is -3/4. 1 minus 1 is 0. 4 minus 1 is 3, and 16 minus 1 is 15. Okay. For my y values, it tells me to multiply them by a -1 first, so change their sign, and then subtract 6. So -2, if I change the sign, is a +2, and then I have to subtract 6 to get -4. All right, take the -1 here, change the sign to make it a +1, and then subtract 6, I get -5. 0 doesn't change sign, so just subtract 6, you get -6. Can you see the pattern here? So I'll just this is -7, that's -8. Let's pop some points. All right, so -15/16 has to go with -4. Okay, -3/4 goes with -5. Come on. 0 goes with -6. 3 goes down to -7. And 15 goes to -8. So that's way down there. Okay. And if I graph things, this graph, I go along my asymptote and I'll go through my points. And so because you're a base of 4, I'd say you're an increasing graph, but this -1 did flip you top to bottom. Okay. Let's talk about an x-intercept and a y-intercept and our increasing versus decreasing. So our x and y-intercepts, our y-intercept is right here at 0, -6. To find our x-intercept, we need to do some calculating. Okay, so to find the x-intercept, I'm going to say something like this. Where does my function equal 0? And I'm supposed to solve that. Okay, so I'm going to add 6 to both sides. I'm going to divide by a -1. And then to keep going, I'm going to rewrite this in exponent form. So this is 4 to the -6 equals x plus 1. So if I subtract 1 from both sides, 4 to the -6 minus 1, that is the x part of my x-intercept. It's really, 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 really tiny, right? 4 to the -6 power is going to be 1 over a super tiny number, and then I'm subtracting 1 from that. So I'm going to leave that as my x value. So 4 to the -6 minus 1, 0. I'm not going to worry about increasing, decreasing on that because it does get confusing. All right. Here's the most complicated one that I want you to kind of see. So on this one, your graph or your base is 1/3. And so that means it's a decreasing function. Okay, that means it's going to go down left to right, just so you're kind of aware of that. You have a 2 on the outside, you have a negative sign, and this whole +1. So that's kind of crazy. Let's look at this domain to start with. Okay, where does -x plus 1, where is it positive, and where does negative x plus 1 equal 0? That'll tell me about my asymptote. And so if I solve this, I can subtract 1 from both sides. I get negative x is greater than negative 1. I can divide both sides by negative 1, and I get x is less than 1. Right? You got to flip your sign. Your domain is x is less than 1. Your asymptote, if you subtract 1, you get negative x is equal to negative 1. You divide, you get x equals positive 1. My asymptote is x equals 1 for my answer there. Range is still all reals. Okay. So if we can kind of go back from there, I'm going to use that x equals 1 to kind of type in my asymptote to begin with. X equals 1 is right here. Okay. And then let's go ahead and figure out our points and plot our points. Our base here is 1/3. So we're going to go -2, -1, 0, 1, and 2. And if I plug in an exponent of -2 with a base of 1/3, I'm going to get 9. Right? Because 1/3 to the -2nd power. The negative makes you flip it. So this is actually equal to 3 squared, which is 9. If I plug in a -1, I get a 3. 1/3 to the 0, because this is what we're really doing. 1/3 to the 0 is 1. 1/3 to the first is 3, 1/3. And 1/3 squared is 1/9. Okay. Let's talk about the inverse part, the log. This will be the log base 1/3 of x. So just switch your points, 9, -2, 3, -1, 1, 0, 1/3, 1, and 1/9, 2. And then to make our final transition here, to get finally what's going on, 2 is the only thing on the outside. So we're just supposed to double our y values. Outside things impact your y values. This inside stuff, though, this is all on the inside. There's a negative sign, which means I have to take my x values and multiply them by a -1. And then look at your asymptote here. Your asymptote means that you shifted 1 in the positive direction, the positive x direction. So I'm going to then add 1 to all my x values. So if I go here to 9, I'm going to make it -9 plus 1, which is -8. 3. Multiply that by a -1, right? Because I'm plugging in here and you always have to multiply first. That becomes a -3 plus 1 is -2. Plug in a 1, that becomes -1. But if I add 1 to it, I get a 0. That becomes a -1/3 plus 1, which is 2/3. And then that becomes a -1/9, but you add 1 to it, you get 8/9. All of my y values are supposed to double. That becomes a -4, a -1, a 0, a 2, and a 4. Okay, so let's plot those points. -8, -4. -2, -1, 0, 0, 2/3, comma 2. Oops, come on. 2/3, comma 2, come on. And then 8/9, comma 4 is somewhere right there. So this graph looks like this. Okay. X and Y intercepts were found. They're already plotted. Both of them are the same exact answer. They're both 0, 0. Okay. And we're not going to worry about increasing, decreasing, because I got confused. Okay. The last types of graphs we have to talk about are going to be exponential and logarithmic, but using base E. Okay. So you do need a calculator for this. So if you don't have a calculator, please go grab one. But if I have to graph e to the x, okay, you should get something that looks kind of like this. E to the x, it's got an asymptote here at 0. It's a growth function, right? E, this is the same thing as y equals 2.71 to the x. The base is 2. It's a bigger base, so it is a growth function. Okay, if you graph ln of x, that's down here, okay, you're still going to have an asymptote. It's going to be like this. And then your graph is going to go along the asymptote, and it's a growth function because, again, your base is 2, right? This is like y equals the log base e of x. The base is just e, and so since the base is bigger than 1, then you know that you're doing okay there. All right, just to practice, plug into your calculator these two values. The ln of 2, hopefully you get 0.6931. For the ln of -1, shouldn't work. Remember, this argument always has to be positive. Always has to be positive, okay? All right, we're almost done here. So if I go up here, if I talk about find the domain for all of these, you've got to look at your argument, the inside of your log. Where does x minus 2 stay positive? Well, that's when x is greater than 2. That would be my domain. For this one, where does 2 minus x stay positive? So that could be 2 is less than x, or if you like it, it's x is less than 2. Okay, this has a negative on it, so that's going to make your graph flip. And so your asymptote would be on the right side, and then your graph will be on the left side on this one, okay? And then we're not going to worry about 3. Okay, so you treat those domains the same as you would before. So if I wanted you to graph the ln of x minus 6 plus 3, what I need you to understand is that the base is still e, so it is a growth graph. It's going to go up left to right. X minus 6 is on the inside. That's going to help me with my domain and asymptote. Where does, x minus 6, where is it positive, and where does x minus 6 equal 0? There's my asymptote at 6. My domain would be x is greater than 6. My range stays at all reals. Okay, and this should be an increasing graph because my base is bigger than 1. This graph then is moving right 6. It's also moving up 3. Okay, so at the end here, I'm going to take all my x values and add 6 to them. And on my y values, I'm going to add 3 to them. What values are you going to start with? Well, e to the x values. And then we'll switch over and we'll do the inverse. So we'll just do the ln of x. And then we'll kind of go from there. So plug in negative 1, 0, 1, and 2 into a calculator and get values. Now, normally I want you to use 4 decimal places, but if we're graphing, we can only go to the nearest tenth. That's the accuracy with which we can graph. So e to the -2 is like 0.14. So we'll graph 0.1. E to the -1st is like 0.4 something. E to the 0 is 1. E to the 1st is 2.7. And e squared will be 7.4. And so we're going to use these decimal values now and just switch them. For the inverse, I have 0.1, -2, 0.4, -1, 1, 0, 2.71, and 7.4, 2. And then all we have to do now is add things to them. So let's add 6. So this will be 6.1. Add 6, so that's 6.4. Add 6, you get 7. Add 6, you get 8.7. Add 6, you get, what am I doing? 13.4, sorry. Add 3 to the y value. So every y value, add 3, so that's a 1. Add 3, you get a 2, a 3, a 4, a 5. So these are the points I really want to plot. Please know that when you are graphing either e to the x or an ln of x, you're going to get a calculator for all of that, okay? Ooh, we decided that our asymptote was at 6. I don't know why it dots for me at the top, but not the bottom. I have no clue. All right, 6.1, 1, 6.4, 2, 7, 3. Come on. And then 8.7, 4, 8.7, 4, come on. And then 13, oh, come on, 8.7, 4. And then 13, 5. So our graph kind of looks like go along the asymptote through my points, and there you go. Okay. All right. So hopefully that's good enough to help you start graphing. That's your homework. If you've got any questions, please stop by during office hours. I can help you in real time. All righty, take care. We'll see you soon.